Okay, we're now looking at some trigonometric equations where some transformations happen. So we're no longer looking at some naive sine alpha equals k, tan alpha equals k. Something has happened to our function here. So for example, this one has been squidged up by a factor of 2 along the x-axis. But really, we don't care what transformation has actually taken place. We're going to do the exact same thing each time, which is this. We are going to simplify this transformed trigonometric equation into a more simple one that we can solve. And we'll do that by introducing this new variable x, which will be whatever is the argument of my new trigonometric function here. So I'm going to introduce capital X as 2 alpha, which is the argument of this sine function here. And I'm also going to update the limits. So you see this original function is going from 0 degrees to 90 degrees. As x equals 2 times alpha, we can update these limits accordingly to be in terms of this new variable x. So when alpha is 0, we know x is 2 times alpha, so x is 2 times 0. So we're going to start at x equals 0. And we're going all the way up to alpha equals 90, x equals 2 times alpha. So we're going up to x equals 2 times 90, x equals 180. Okay. Now you see in this new situation, we have basically a very simple trigonometric equation. There's no weird transformations taking place, and we can solve this one very easily in the normal way. So we're just solving this sine x equals 0.2 between 0 and 180 degrees. So I'm going to find my first solution from arc sine 0.2. So let me fire up that calculator. So I'm in degrees, shift, arc sine 0.2 is, we'll call that 11.5 degrees. 11.5 degrees, and I'm going to find the other solution using the cast diagram here. I've drawn an axis, but I'm actually just going to use the unit circle. So if we are here, this is my first answer, 11.5 degrees. Now to think where I'm going to find another solution, I noticed that sine is positive, so I'm going to think in which quadrant will there be a sign that is positive. Well, it's going to be this second quadrant here. Sine will be positive, so I can draw my second solution here. Now, for it to have the same magnitude, remember this is the sine of something is the y coordinate here. So for this y coordinate to have the same magnitude, I have to be deflected the same amount from the axis. So that's going to be 11.5 degrees here. And I can work out this angle from my starting position. If I know that the whole journey across this semicircle is 180 degrees, this is going to be 180 minus 11.5 degrees. So that's going to be 180 minus 11.5. So this is 168.5. So I have my two solutions are 11.5 and 168.5 degrees. Now we've solved for x, so the only step that we have to do at the end is this. We have to find alpha. We have to recall that x equals 2 alpha, so alpha equals x over 2. So that means alpha equals 11.5 over 2 and alpha equals 168.5 over 2. So to recap, we had a transformed function, we introduced a new variable x, which was whatever this argument is, we updated our limits accordingly in terms of this new x, we solved the simple trigonometric equation, and then we reverted back from x to alpha to find our solutions. So let's do one more. We're going to do the exact same thing pretty much every time. So I have sine minus 2x equals 0.6, so a different transformation has happened. It's been reversed over the y-axis and squidged up. We don't really care what's happened in the transformation though, we're just going to follow the same steps. So new variable capital X is minus 2 lowercase x, and we're also going to update these limits. So we're going from 0 to 180, so we're going from x is 0 to x is 180. Capital X equals minus 2 times lowercase x, so it's minus 2 times 0 and minus 2 times 180. So x is going to be going from 0, well, going between minus 360. So here we go. So we have capital X minus 360 and 0. So I'm looking for all solutions between minus 360 degrees and 0. Sine x equals 0.6. Again, I'm going to bin off the graph and I'm going to use the unit circle method. So we're going to find our first solution x from arc sine 0.6. So we go shift arc sine 0.6, That's going to be, we'll call that 36.9 degrees. So we'll call that 36.9 degrees. So let's draw a unit circle. That was a very squished unit circle. Let's try that again. Here is a beautiful unit circle. That is a beautiful unit circle. Here is this, and we've got our first solution here at 36.9 degrees. Okay, now we remember cast, C-A-S-T. Sign here is positive. So I think, which quadrant will I be in to have another sign that is positive? Well, we're going to be here in this second quadrant. They have to have the same deflection from the y-axis. So I know this angle here will be 36.9 degrees. And that means my second solution will be this angle coming across, which will be 180 minus 36.9. So I have 180 minus 36.9. 143.1 degrees. So that's going to be 143.1 degrees. Now notice, neither of these solutions are in my range, which is minus 360 is greater than x is smaller than 0 there. So what I'm going to do is I'm going to take both of these numbers and I'm going to use the periodicity of sine to find some solutions in this region. So what I'm going to do is I'm going to take 360 degrees away from both of these solutions and see if we can find some values in this correct region. So I'm going to do 36.9 minus 360. So 36.9 minus 360 minus 323.1. So minus 323.1. That is in the correct region. And then let's try this one. 143.1 minus 360. 143.1 minus 360. Is minus 216.9. So we've got minus 216.9. So those are both solutions in this correct range here. Now, we've got x. We need to remember that we were asked to find alpha. So x is whatever this is. Let me just click and drag this down a little bit. So x is this. X is minus 2 lowercase x. So my lowercase x is capital X divided by minus 2. So that means x equals minus 323.1 over minus 2, and x equals minus 216.9 over minus 2. So x is whatever that is. So minus 323.1 minus 323.1 divided by minus 2. I mean, the negatives are going to cancel here. So that's 161.55. Excuse me. Right. 161.55. We'll call that 161.6, and then we got minus 216.9 over minus 2, minus 21, was it 216? 216.9 over minus 2. 216.9 divided by minus 2 is 108.5. 108.5. 108.5. Cool, and we have our two solutions. And for this last question on the worksheet, we do the exact same thing. So we introduce a new variable x. X is whatever this argument is. So that's alpha plus 20. We'd update our limits. So in my original equation, I'm going between 0 and 180 degrees. So I'm going to be going from 20 to 200 degrees. And then we would solve this more simple trigonometric equation. So now I've just got this going between 20 and 200. I would do arctan to find my first solution, and then go ahead and solve. And then right at the end, I would have to come back and find x. So hopefully that helps with these trigonometric functions where some transformation has occurred. All we do is we take that argument, introduce that as a new variable, update the limits, solve, and then come back and finish the job for that original variable.